Hello everyone, this is just a quick addendum to the previous video. So inside a long, thin solenoid, the magnetic field can be calculated, and it is approximately equal to mu times n times I. This equation is not assessed in the IB. This equation refers to the magnetic field strength sort of within the solenoid itself. Importantly, in the original notes, and I'm just going to make a note of this, this just said number of turns, but this is actually the number of turns or coil density, so the number of turns per unit length. This value right here is how tightly those coils are packed. That's a way to think about it. So the magnetic field is proportional to the number of turns per unit length, the current strength itself, and the permeability of the material inside it. Okay, now in air or in a vacuum, that value can be looked up. It's 4 pi times 10 to the negative 7 newtons per ampere squared. But as it turns out, by changing the material inside the solenoid, you can drastically impact the magnetic field it produces. And in particular, you can make what's known as an electromagnet. How do you do that? You take an iron core and effectively increase the permeability of the inside of the solenoid. So you add an iron core or other ferromagnetic material, and as a result, that material can be induced to be magnetic. So as the magnetic field lines sort of penetrate that core material, that iron, the domains inside the iron, that is the little bits of iron at the molecular level, align with the external field, and so that iron produces its own field, reinforcing the external magnetic field. So it changes the permeability of the material inside with this phenomena of induced magnetism, and makes the overall field much, much stronger, as much as a factor of 5,000 or so. So the individual parts of this iron bar can be thought of as having little north-south ends that all align with the external field and reinforce it. And this setup is known as an electromagnet, and it's a very, very important aspect of a lot of modern industries. This is how we make and control magnetism in most industrial applications.